Different metals produce different colors when they are put in a hot flame. This is the basis of atomic absorption spectroscopy, used to identify the elements in samples of water. Flame tests are carried out on samples of ionic substances. The most intense colors are obtained from solids, but flame tests can also work when solids are dissolved in water. Flame tests have led to the discovery of new elements. In 1860, Robert Bunsen and Gustav Kirchhoff used simple spectroscopy to study the light given off in flame tests by some samples of mineral water. They used a prism to separate the colors of light into a spectrum and saw a grey-blue color that had not been seen before. They realized they had discovered a new element, which they called cesium, after the Latin word for sky blue. A year later, using the same technique, they discovered another new element. They named it rubidium, after the Latin word for dark red. Certain anions can be identified by precipitation tests. To identify aqueous chloride solutions, Cl-, a few drops of dilute nitric acid are added to the sample solution, which is then shaken. A few drops of silver nitrate solution are then added. A white precipitate of silver chloride forms if the sample contains chloride ions. To identify aqueous sulfate ions, SO4-2, a few drops of dilute hydrochloric acid are added to the sample solution, which is then shaken. A few drops of barium chloride solution are then added. A white precipitate of barium sulfate forms if the sample contains sulfate ions. Carbon dioxide is given off when an acid is added to a substance containing carbonate ions, CO3-2. Lime water is used to confirm the identity of the gas. Lime water turns milky when carbon dioxide is bubbled through it. So by adding a carbonate to an acid, and the fizzy bubbles turn lime water milky, is a test for the presence of carbonate ions.